Okay, so let's talk about the lab. You are going to have 8 beakers of liquids. 5 of those are going to be labeled with known percentages of sugar, 0, 5, 10, 15, and 20. And the other 3 are going to be unknown amounts of sugar. Okay, and we're using Coke, grape Fanta, and Gatorade. Okay, so you are going to use mass and volume to identify the density of all of those. Okay, and then I'm going to show you how to use that density to determine percent sugar. Okay, so the first thing you need to know, we're using a 10 milliliter graduated cylinder. All right, so the first thing we need to do is find the mass. So when you find the mass, you're going to put the graduated cylinder on the scale. All right, and then hit the 0 button. So when you look at the scale or you look at the balance, it should have the graduated cylinder on it and say 0 at the same time. Okay, so then you take that off. Then you're going to add just 8 to 10 milliliters of liquid. Okay, whichever one you're on. 8 to 10 milliliters. It doesn't make any sense to sit there and waste time trying to get it exactly to 8 milliliters or 9 milliliters or 10 milliliters. Just put it in there, read it to as the most accurate level as possible, okay? And mark that down as your volume, okay? So once you've got the liquid in there, you bring it back to the scale, and you put it on there, and that's your mass. All right, so you're concerned with mass and volume at this point. Okay, for all 8 of those, there's 2 ways you can do a table. You can do it on paper and make it look like this, or you can just fill it in on the computer as you go. It doesn't make any difference how you do it. All right, eventually we're going to put it into the computer, so most people like to just have their computer there and putting it into the spreadsheet as they go. All right, so now that we've got our table filled in, all right, you've done all the masses, you've done all the volumes, all right, we still need to calculate the densities of those. Okay, so we're going to go, we're going to open up a new sheet. Okay, open up a new sheet. We're going to fill in our data. Now, it is important that you fill it in exactly as I'm showing you now, so you won't have any issues with your graph. Okay, so the first thing is going to be the liquid. Okay, and then we've got our mass, then our volume, then our percent sugar, and then our density. Okay, now fill it in like this. All right, don't change don't change any of these, just fill it in like this. So our liquids, we got 0%, 5%, 10%, 15% and 20%. Those are the only ones we're concerned with right now. All right, we'll do the rest of them later. So through the course of doing this experiment, these masses are what I got. Okay. And then when I found those volumes, it was these right here. Okay. These numbers right here are just whatever you found. All right. However much liquid you put in each graduated cylinder and how much mass that was on the scale. Okay. Again, percent sugar. I know this seems a little redundant, but it's going to help your chart out later. Okay. Now, our density. Density is mass divided by volume, okay? D equals M over V. So we are going to put this into the spreadsheet as equals the mass divided by the volume, okay? So this column divided by this column, and press enter, okay? Now you can do that for each cell if you want to, or you can use this little fill handle. Surely you all know about that. Okay, so there's our densities right there. All right, so this is what we're going to use to make our chart. Okay, so we're going to highlight these right here. Click Insert Chart. Right. you need to click right here. This is a scatter plot. All right. And then go to customization. We're going to put a title. So it's percent sugar versus density. Okay, and then we're going to come down. The horizontal axis, or the x-axis, is our percent sugar. Give it a title. And then we have this drop box, and we go to the left y-axis, and this is your density. Okay, so that's going to give you your titles. You need your titles in your lab report. Okay. Now that we've got that, now we need to find our line. We're going to do our line of best fits. We scroll all the way down. This trend line right here, we're going to click linear because we want it to be a straight line. Then you're going to scroll down even further and label, instead of custom, you're going to say use the equation. And that's going to give you the equation for that line. Okay? We're going to need that. So you're going to insert that right there. I would drag it down a little bit because you're going to use this space next. Okay? Now, we've created our chart. That's all we need these densities for. So now we're going to use the three unknowns. Okay, so we have a drink, we have mass, we have volume, we have density, and then we are going to calculate the experimental percent sugar. Then we're going to put in the actual percent sugar, which I'm going to tell you what that is. And then our percent error. Okay. So all of these are going to be filled in. So we've got our Fanta, our Coke, and our Gatorade. Okay, so again, we found the mass and the volume the same way that we did with these other liquids. So when I did that, 9.54, 9.32, and 8.69 as my masses, and my volumes are 9.22, 9.03, and 8.56. It doesn't matter what they are. You get what you get. Okay? And again, our density is equal to mass divided by volume. Okay, and press enter. So now we've got our densities of these three. So now we're going to basically use this line to interpret this data. Okay? So our experimental percent sugar, we're going to use this line, this graph right here. Okay? So let me show you how to isolate the X. All right? We're going to isolate the X and use that. Our equation here is y equals 0.003636x plus 0.992. Okay? So we want to isolate this x right here. So we're going to go minus 0.992. Y minus 0.992 equals 0.003636x. Okay? And now we're just going to divide by 0.003636 on both sides. What we end up with is x equals y minus 0.992 divided by 0.003636. Okay? That's the equation that we're going to put into the spreadsheet. Now, y here is your density. Okay? And x here is your percent sugar. Okay? So let's go back to our spreadsheet. Okay? So equals, okay, and we said it's the density. Sorry, we got to put some parentheses there. So equals parentheses our density minus 0.992 992, close the parentheses, okay, and then divided by 0.003636. Okay, and there's our experimental percent sugar. Use the fill handle to fill in the rest of them. Okay, now the actual percent sugar for Fanta is 11.4%. Okay, the actual percentage of sugar for Coke is 10.4. And the actual percent for sugar for Gatorade is 6.2. All right, so now we have our experimental percent sugar, our actual percent sugar, and we're going to calculate percent error. Okay, percent error is, and you can use the absolute value function if you want. I think that's probably a little bit more confusing here than it needs to be. So just take the positive value of it, or the absolute value of it. Okay, so if it's a negative, just take the negative sign off of it. Okay, so you are going to have a parentheses, and then your experimental minus your actual, close the parentheses, and divide it by the experimental. Okay. Now, you can do one of two things. You can add, right up here, you can add times 100 if you want to, or you can highlight all three of these and press this button right here, format as a percent. So now it's 2.94% instead of 0.0294. Okay, had we multiplied this by 100, okay, had we done this formula right here and multiplied it by 100, you would, and not done this button, you would have gotten 2.94, okay? It just wouldn't have a percent sign on it, okay? So these are the two tables you need to put into your lab report, okay? You need to have all three of these things. This table right here, this table right here, and you need to have this chart, okay? All three of these are critical components to your lab report, all right? Follow this exactly as I've done it, and you will not have any problems, okay, creating your graph or calculating your numbers. Now, you do have to use your own numbers. These are the numbers that I got when I did the lab. You need to use your own numbers when you're calculating your results.